Good evening.
Good evening.
I got a couple of hellos. Hello. Has anybody here actually played around with Android or Kotlin in the room? A couple of you guys? Great. This is probably just going to be pretty basic for you. But I have to tell you, as somebody who has done .NET for quite a bit and done tests very differently, it was really interesting to discover the way that things are done. So I decided I wanted to share this because I didn't actually have the same kind of experiences piecing this together as what is usually now available, directly on the website for Kotlin or for TDD in general. I also came from a proof of concept background where we didn't write tests. I know that sounds terrible, but we actually had people who would test for us, so I don't have to worry about that. And I don't know if all of you ever came from that background where you start up as a consultant and you just want to get something built. But then I got put on a team most recently that had this approach. And I thought it was kind of cool, and I wanted to share things that I liked about it and things that I didn't like about it. So for those of you who do this all the time, this is probably just a little bit more of a basic refresher. But for me, it was exciting to go through the process of learning TDD, what it really was. So this is about a little heavy on the TDD, a little light on the Kotlin, because luckily for us, Kotlin makes it easy. So that's a little bit about what this is about. For those of you who don't know me, my name is Heather Downing. I'm really into innovation and enterprise level stuff. I like to do consumer-facing applications, and some people know me as a speaker. So if you're interested at all in additional things that I do, you can follow me at Coraline on Twitter. All right, if you're interested in what we're going to cover today, let me give you a little overview. All right, we are going to kind of just go over the kind of case study that I was given, just a real basic one. I had the original case study completely written out, but sometimes the way that it goes is that you're not allowed to share some of those details because the company doesn't want to sign off on them. And unfortunately for me, they just decided not to. So instead, I went ahead and gave an example, but I will kind of just go into a little bit more detail about the kinds of implementations that we did. I'll also give you a brief introduction to test-driven development, because like I said, that was one of the things that I discovered during the course of this application that we were building, and what is the difference between TDD and behavior-driven development. Also, a little introduction to how Kotlin fits into testing. It's not Kotlin itself. I don't go through the whole language. It's awesome. I'm going to give you that as a forewarning, but I just go specifically into how Kotlin applies to testing and using TDD in a proof of concept approach, what we think about that. The coolest part of this entire thing was my discovery of an easy kind of 5-step method of how to approach TDD, because until that time I was very overwhelmed with how much extra work it felt like and how much my brain disliked it. We're going to go into a little bit of a collaborative game. I know there's not very many people, but hopefully you'll kind of interact a little, and some key takeaways. So this is what we're going to cover today, and this is, again, quite interactive. So anybody have any questions before we start? Yes? No? Awesome. So I used to call them client objectives. This is a case study kind of about that. Probably most of you in the room are on a team, yes? Is anybody here just on their own, like consultant? Yeah, well, you are. Awesome. Awesome. Have you ever been in a team before, though? Okay. Most companies have a process of how they break down the tasks we got to do. This is not the talk for that, but most of us know it as the agile process, right? It usually is interpreted depending on how much you need it. But the reason I'm putting that up there is because this started from a place of just a simple user story. At first, we were just saying, yeah, we can build an app in like 4 weeks, 5 weeks, 6 weeks, whatever it is. But the amount of time that we quote quite often has nothing to do with thinking about the testing. We don't think about the additional testing of a QA person. We don't think about the testing of our client, let alone thinking of the tests before you write them, right? I was thinking, this is how long it would take for me to implement this. The problem with giving a lot of just a ballpark. Usually the client engagement person will kind of rope you into, oh, just give me a ballpark idea how long that would take. And so whatever you say off the cuff is probably wrong. You need to double it and then triple it for good measure. And so when I tell someone, oh, implementing that screen, it'll take me a week. Won't really. The actual implementation will probably take a lot less than that. But because we have to iron out all the details of what they really want, that's probably how long, realistically, the entire process is going to take, okay? So now we're kind of up against this deadline where we signed a contract and no, we have to deliver it week 5. Whatever state it's in, we deliver it. So I'm really interested in how we're going to achieve this 100% test coverage mystery in 5 weeks. To me, that's a lot of extra work, to be able to do that. Not that testing isn't good. It's that how do we make sure that we cover that? So the way that the team that I worked on approached it is that, well, we just do everything TDD. And I'm like, wow, that's not a lot of time for that. Are you sure we have time? And they said, oh yeah, eventually once you get good at it, you can build it in the same amount of time. So what I'm going to kind of walk you through is what actually happened, because again, we all have different holes in our backgrounds, right? There's a lot of things that I know a lot about that you probably don't, and vice versa. My particular hole is that I didn't ever follow the TDD way. Like, I had always just played around until something got to work, and then maybe I would write a unit test later to make sure that we had some test coverage for it. But I had never written tests first. My brain wasn't thinking that way. My brain thinks as an implementer, right? So a user story that I get, like day one, kind of looks like this. As an administrator, I want to be able to create user accounts so I can grant users access to the system. This should be what they call a small pointed ticket. And I'm like, okay, great. As the team that we were on was also an XP shop, that meant that more than one of us would actually sit at the computer at the time and work on this, right? There was nothing else in the ticket except for this. So that's all that they felt that they needed to give us. And I'm like, oh, I think I understand the basics here. I can go from there. But because of the way that TDD can work, it actually needed more acceptance criteria. It needed better acceptance criteria. So that basic statement started being able to be broken down further and further. Good acceptance criteria might be a list like this. If I'm an administrator, I can create user accounts. So right there, that is one piece of it. I can create a user account by entering the following information about the user, XYZ. I cannot assign a new user to report to an inactive user. Oh, that was important to know. Didn't know that. Now I know that. I cannot assign a new user to report to a user if it creates a cyclical relationship. Yeah, that's pretty self-explanatory. And the system notifies me that it sent an email to the new user's email address containing a system-generated initial password and instructions for the person to log in and change a password. And I am able to verify with the intended recipient of the email that it was received. There's a lot more going on in that ticket than I originally intended. So what is starting to happen here is that as a developer, I have to ensure I have good acceptance criteria or I don't work on a ticket. That was new for me, because usually as developers, we're the last ones down the road after all the decisions are made. We're kind of left holding the bag. Well, we spent all this time on design and hashing out what we think it needs to be, and okay, now you just need to hurry up and do it. But by approaching it this way, what I was fascinated to see is that we actually had power to push back and say, well, we can't write tests for this because I don't have enough small chunks of acceptance criteria so that I can do those things. And that was something I felt was very beneficial, because these are really easy black and white things that a client can say, oh, yeah, I wasn't specific about that. And so the onus is not on you to deliver like something that was complete in 5 weeks. The onus is on them to give us complete acceptance criteria if they want something accurate. So that was something that was kind of like a side thing that I really felt was valuable. So now that we have our good acceptance criteria, This was my first introduction to TDD. Cool. Has anybody in here done TDD as an approach? Okay, a couple of you. Cool. So come along with me. I didn't even really know what it was. So, of course, like everybody else, I started Googling it. Basically, you write a failing test, you make that test pass, and refactor, like that. That's all it is. TDD can be defined as a programming practice that instructs developers to write new code only if an automated test has failed. So this avoids duplication of code, and TDD means test-driven development. The primary goal of TDD is to make the code clearer, simple, and bug-free. So this is the intention behind this. A lot of people just refer to it as red-green refactor. Okay? This was an interesting concept to me because I've never written something on purpose that doesn't work. Like, usually it's an accident. So it was a huge paradigm shift for my brain, and my brain didn't like it. So I really needed a little bit more of an example of what that is. I needed some clarifications about TDD. I needed to know that TDD is not about testing or about design. It's also not write some of the tests and then build a system that passes the tests. It does not mean do lots of testing. So I was a little bit confused as to exactly what kind of approach we were supposed to do. How far down the minutia did we need to go with all of this? It felt really overwhelming. And the only reason it felt overwhelming is because I love building, but this felt like taking an exam all the time, right? It felt like taking an exam, and that kind of took the joy out of it. But then something else was kind of introduced to me as a concept, is that TDD gives you confidence that what you have written can be automatically tested and completely covered no matter at what point your budget runs out, no matter at what point you have to hand it over. You know that you have tests for everything, and that is valuable production code. And I was like, but if they didn't get a whole system within that 5 weeks, is that valuable? It's interesting just to kind of mull over your head. So I started looking into TDD just a little bit more, and I discovered an interview with Robert Martin, Uncle Bob, about his 3 laws of TDD so that I could think about the way to situate my brain. Number 1, you are not allowed to write any production code unless it is to make a failing unit test pass. And it has to be in the smallest way. So if you write something to call a function that you haven't written yet, that fails. So that means the smallest amount of work that you can do to make that pass is you create a blank function that passes null. Now the test passes. That was weird to me too. That is like writing a red test, getting it to pass, and now we have to refactor that to really be more of what we mean. So that means it's very, very small, very incremental. This actually worked really well with some of our junior developers who had to slow down and think in smaller pieces. Absolutely. Law number 2, you are not allowed to write any more of a unit test than is sufficient to fail, and compilation failures are failures. Also kind of blew my mind a little bit. And his 3rd law, which is, you are not allowed to write any more production code than is sufficient to pass the current failing unit test. So that means if you do something within your production code that actually causes any sort of a cascade effect, you're only supposed to do one at a time, only fix one at a time. And if you can't fix one at a time, that's an artifact of something that is too tightly coupled. So that promotes a decoupled kind of system, which of course is something that we all want to get to, right? We want to be able to swap out any sort of calls that we're doing. So now that I'm a little more familiar with the way to think about it, how do I name all of my tests, right? So there is a process in place that many people use. There's a couple of different ones. The one that I'm going to show you is a given when then. Anybody familiar with that? Yes, a couple of you? Okay, for those who aren't, given is the preparation, okay? It's the object that's under the test initialization, okay? That's usually where any of your stubs or mock creations of your object will happen within your test class, and any injection of dependencies, okay? It kind of looks like this. Given user is logged in, okay, this would be the beginning naming of your test. Given when this happens, when would be the execution, okay? An operation to test in a given test. It could look like one of those, like when a user launches the app or when the user clicks log out, okay? Then is the assertion, okay? This is the important, I'd argue, part of this test. It processes the received result and verifies any mocks that you have. And it might look like this. Then the user sees the logged out text. This is very small, right? A very small test to me. There are additional frameworks that some of the really major applications companies have put together that actually makes this a little bit easier. One of them is Shazam. Has anybody ever used Shazam? You know, to listen to music and it processes it and tells you who the artist is. Shazam wrote their own test framework in Kotlin so that they actually could chain method calls that makes it very easy to read. Kind of look like this, right? I mean, look at the extension methods all the way down, right? It's just an example of their helper framework, okay? I thought that was pretty cool, but it's not something I can use because it's proprietary to them. So really, I needed to think about it in the most basic, what ships with Kotlin way, which is kind of like whatever unit of work, the statement under the text, and the expected behavior, okay? When really, if I wanted to, let's say, create a password validator, okay? All I'm thinking about is something that looks like this, right? I just want a basic validation method. To me, there is only one test because there's only one method. So all I care about is what goes in and out, right? Much to my surprise, it looked more like this. So there really was like 4 tests for that one function because there were 4 different kinds of cases that can come out of this. And this can go on and on. There can be quite a bit of it. You can only test what you know. You can only write tests for what you know should or should not occur, right? So as you go, you may add additional tests for existing functions. Also, as QA does their job and discovers things, you have to add additional tests. Blew my mind. So instead of me writing just that one function, now in my brain, I wrote 5, but 4 of them were tests, right? Very different way to think about it. But if I change anything in my function, don't I want it to be caught somewhere? If my test mirrors my function exactly, then there's not a lot of value in that. There's not a lot of changing what the data is that goes in, right? All of those test cases. What is very cool about Kotlin is you can use backticks to name your methods or classes as you like. It would look like that. A little bit easier to read. One of the best parts of this language is its human readability. And I know I kind of jumped ahead before the introduction to Kotlin part, but this is the reason why I thought I would jump in the pool with it. Because there's lots of different kinds of test frameworks that are available for all different languages, but this is the first time I saw a language built in that can do this kind of thing. So anytime anything would compile and I'd get errors, it was as if somebody wrote me a book or a tweet. It was very cool. This is 100% human readable. Even someone who has no idea what test or class is doing, they can read the method name and understand the purpose, right? Even more, if you've already some test cases or scenarios written, they can be easily transformed into these unit tests by copying and pasting titles of your test scenarios. And this includes Java. The great thing about Kotlin is it's compatible with Java, right? So you can write tests in Kotlin for code that already exists. Pretty cool. And that brings me to the difference between TDD and BDD, or behavior-driven development. Too many anachronisms. Oh my gosh. That is one part of our industry. You gotta work on the jargon. Behavior-driven development is perhaps the biggest source of confusion during this part of the journey. When it's applied to automated testing, BDD is a set of best practices for writing great tests. BDD can and should be used together with TDD and unit testing methods. So now I'm like, oh, so now I need to know this too. All right. Really, behavior-driven development allows test focus on the desired behavior or outcome. It actually, hilariously, decouples the naming of the test from what the actual functionality is doing at the integration level. And I'm like, that's interesting. A common problem with poor unit tests is they rely too much on how the tested function is implemented. So that means that if you update the function, even without changing the inputs and outputs, you must also update the test, right? This is a problem because it makes doing changes very tedious. So behavior-driven development addresses this problem by showing you how to test. So you should not test implementation, but instead behavior, okay? So with it, unit testing gives you the what, test-driven development gives you the when, and behavior-driven development gives you the how, okay? Although you can use each individually, you really should combine them for the best results because they complement each other really well. So now I kind of add a little bit more of a framework for how to think about TDD. I had never really messed with Kotlin before. The last time I had touched Android was definitely in the Java days, and that was back before a lot more work was done on it, right? Mobile has come a long way. It's been very interesting, specifically watching both iOS and Android change what their recommended languages are for building. It's been pretty cool. Did anybody use Java or Objective-C to do any of those? Yeah, completely. So you know. Wouldn't you agree that both platforms took a step in a much better direction, though? Like a little bit easier to work with, definitely much more up to snuff, but there's still a lot of power in using those other languages, and a lot of developers still do. But it was very cool to watch this language grow and then get adopted by Google as their official one for Android. It was really neat. So let's introduce Kotlin and why I think it's cool. Kotlin is very concise. The less code you write, the fewer mistakes you make. It's also very expressive. You can express whatever you want in a shorter way because Java is quite verbose, right? What I thought was also interesting is when I first used Java, right, I had done it after .NET, after C#, right? So I always thought was like, oh, C# is like just a little bit more brief, but they're very similar in a lot of ways, right? They have their own run times. They're both object-oriented. There's a lot in common. I just noticed that I could do some things a little quicker, a little less verbose in C#, and Kotlin is even more so. But it's much more compatible with it directly. It's also pragmatic, straight to the point without a lot of writing. It doesn't take a lot to get something to build. It's also type safe. Hooray! Remember the $1 billion mistake. It's really important that you have something that you don't have to think about too much. I really appreciate a good JavaScript developer because of this. Because it's not a type safe language. TypeScript is, but it's just interesting that they chose to go this way as well. Kotlin is also functional. So has anybody ever done any sort of functional programming in the room? Cool. Yes. Have you ever swapped out trying between each of these in Kotlin? Yeah. Yeah. Very cool. And what's neat is that functions and properties are first-class citizens in Kotlin. Very cool. It's also friendly. So I think I mentioned it before, but interoperability between Kotlin and Java works almost perfectly. It's very awesome. And it's human readable. That was the thing that drew me in the most, because I had a choice between doing Kotlin or Swift on this project, and I could have, chosen to work on the iOS or Android implementation, and I really appreciated the way that Kotlin was put together. The best thing that, apart from improving readability, it's also better understood in the output of a result when it fails. You can see the readable error much more clearly after something like this. So, any questions? Very good. Awesome. So this was an interesting part And remember, I think I mentioned that I worked a lot on proof of concepts. At the company I worked with at the time, they would give me a couple of days, maybe, to come up with something that they wanted to impress a client with, as please give us a budget to do the real thing, to do production. But they needed something in their hands because most clients don't know what they want until they see it. And they're like, okay, Heather, we need this on Friday. It is currently Wednesday morning, And I'd be like, ooh, okay. Like, usually there wasn't pressure for me to stay up all night or anything, but it was, can you give us something that we can just show them? That means you break a lot of traditional rules in production code to deliver something that quickly unless you are just that speedy. And it is possible to be that speedy in a lot of ways. But remember, you also have to deal with deployment and the like. If this was a cloud-based app, I'd also have to deal with deployment to the cloud. Nice thing about mobile is that you can put it just directly on someone's device and just hand it over so they can look at it temporarily. You don't have to worry about deploying it to the app stores, at least not for proof of concepts. After working on this whole project and delivering what we've delivered, I can tell you pretty strongly that my opinion of using TDD in proof of concepts is don't. There's just too much to it. It's not that you can't do this well in production code. It's a lot to do in that short amount of time. It's very verbose. But if you have to do any exploratory work, you don't truly know what's possible until you research it and try some things out, especially if you're new to either the framework or Android in general. You have to kind of do a little bit of research as to what classes do what, and you have to know those things before you can really write a red-green refactor test scenario. You'd have to know a little bit of it. So that is a limitation that I saw specifically using TDD with proof of concepts, is that you'd have to already know a lot about what you're working in order for that to really go. And not that you can't write tests for proof of concept, but if it's not production code, what is the value in it? It either works or it doesn't when you're presenting it. Okay? So that's just definitely my opinion, but especially when it comes to what clients want, is that most clients don't really want to pay for extra tests to be done and see almost nothing. They would like to see something. Okay? So I think the answer to this question really is, where does the value lie? Okay? It definitely lies in something that is going to be maintained and created for the long haul, but not necessarily something that just needs to be done very quickly. Because if you got lots of time and you really know how you're going to do it, maybe you can try. I mean, if you have a lot of time to present that proof of concept, just go a little bit lighter. Because TDD is valuable as a tool. You need to use it when it fits and don't use it when it doesn't. Which is also the same thing for doing things in software development in general. How agile are you? What does agile mean to you guys? How small and iterative do you want to be? Does that mean you have no planning up front? These are questions that we ask all the time. If it works, continue using it. If it doesn't work for you guys, then don't do that. I know lots of different groups that just say, let's just have a brainstorming session for several hours, which by the way is planning, and see if we can flesh something out and go with it. That sounds like it's agile to me, but to other people, they're like, that's technically more waterfall-ish, Semantics, do what works for you. That's really the most important thing that I've learned, is that when you want to be valuable as a developer and you want to deliver something pretty quickly, sometimes you have to adjust the processes that you have, and you have to be willing to speak up to your management team or the team you've got around you to say, just ask the question, what is important here? Is it important that we deliver something in this time, or is it important that we deliver 100% test coverage? Sometimes the answer is both. Then that means you have to decide how much of that code you can give in that time, right? And nobody wants to hear that. They want to hear all of the above. But remember, something's got to give. So don't be afraid to be the one to be realistic in that way. Okay, let's do some sort of a collaborative game, shall we? At least one or two of you will hopefully do this. I'm going to go ahead and give you some scenarios based on the given when then. Okay? given that the state of the world is X, when something happens, the state of the world now looks like Y. Okay? Like, given my bank account is in credit and I made no withdrawals recently, when I attempt to withdraw an amount less than my card's limit, then the withdrawal should complete without errors or warnings, which is what I always hope for every time I buy a Noble ticket, right? I am like, please go through every time. But that's mostly because I'm out of the country and I just never know if anything is going to get pinged or if it's going to go through. A good trick that prevents most of the accidental misuse in the given, when, then is to use past tense for given clauses, present tense for when, and future tense for then. That was helpful to me anyways, and this makes it clear that given statements are preconditions and parameters, and that the then statements are post-conditions and expectations. So when your application lifecycle needs to be taken into consideration, this is very useful, specifically when you're doing things like showing and hiding screens and when they appear and when they disappear. So make given and then passive. They should describe values rather than actions. Okay? Make sure when is active. It should describe the action under the test. And try having only one when statement for each scenario. Remember, we went from like one function to 4 tests, right? I'm going to give you a case. And you guys can just let me know how many things we could probably build from that, right? Okay. As a user, I want to be able to log into the app once and not have to do it again. Okay. Right? So, given what? Anybody know?
The user is logged in.
Yeah. So given the user is logged in, when what?
When launching an application.
Okay, so when app launches, okay, or when like main activity is running, okay, that's fine. Then what? What?
User is still logged in.
User is still logged in. So you're checking a bool for that, right? So we have now written the condition of a test that doesn't exist yet, right? So that means all I'm going to do is write, is just assign a bool and make it true. Does the test pass? Yes. Is that useful? No. That means we have one test, right, that passes. But that doesn't actually do what we really, really need it to do in order to fulfill this user story, right? That's just one of them, right? So we know that we need a bool that gives us an answer. So what's the next one? Given what? Yeah. This is what I had to go through, by the way. It's like, given what? You might have the same given, by the way. It might be like, yeah, I know, right? This is...
The authentication information is passed into the next function that you're calling.
Okay. So given that this function...
Sign on is supported.
Yeah. So given that some function name, okay, has received true or false, then what?
The application launches or the functionality is accessible.
Sure, absolutely. So that's one test, right? So then we write an additional method that takes in or at least checks that bool and then does something. So if the user's logging in for the first time, that's one test. Saying, when the user logs in, I want you to change this bool to they're logged in. When this user logs in, I want to store their information. When this user now you see, it adds one and adds one. So now that we are thinking, that's already 4, okay? Right?
When the user hasn't logged in, they can't launch anything.
Okay, so now we have a negative test, right? When the user is not logged in, I cannot launch the app. Right. So this is all tied to just one user story, right? And it's in my brain, it's still one function, but really it's different pieces of it. Okay. So let's try a different one. As a user, I don't want my password to be shown when I type it. Right? Yes.
Quick question here. Do you tear down like every test case you write, because first one is kind of dependency on other tests here.
Oh yes. Yes.
So how do you
Okay, so that was a very good question, by the way. So your question was, what if there are dependencies on the other test passing?
Yeah.
There are not dependencies on the other test passing. They individually are run. Whether or not things need to be in place in order for later tests you write to pass is the point of the red-green refactor. The idea is that you're writing pieces of that test. Right now, you just need something to do this. You're like, well, that's not that useful. I need to do an additional step in order to write a test that will be more useful, right? You start with the smallest and then you continue to go. But they are still run independently. You should be able to hide all the other tests and run them individually and have them still pass. Does that make sense? Yeah. I know. So for me, it was very difficult because when I started, I'm already 12 steps ahead thinking about the next thing, okay? And the practice for me was, what is the first thing that needs to happen, or what is the smallest thing that can happen? And I thought it was kind of silly. Even Uncle Bob said in his interview, he's like, okay, so I have to write all this stuff and it's extra code, and I actually write less production code than I do tests. So there's way more code in my test classes than there is in my production code. And he's like, yeah, but that's a good thing, because you want it to be as small as possible to do the least amount of work and completely decoupled. That was the idea. Yes?
Would you say it's accurate to say that any dependencies that you have would be referenced in the given for each test?
I think that's probably accurate. So that was a good point. So just to repeat, any dependencies maybe that you would need should be referenced in the given statement. So like, given my user is logged in, or given I do have this password, or I don't. That indicates to not just like the human eye, but also as you're building this, what you should be expecting. So a strange thing started to happen. I started not wanting to write a lot of tests, which means I started to want to do the simplest thing possible and not make it complex, at least in my production code, because I already have 4 or 5 tests for just a basic thing, right? And that was a good turning point for me, is that I realized that in a way, even though it's more work to write tests, it definitely made me not want to write more production code. Okay? And I know that sounds strange, but it was smaller. Like, our files were smaller. We actually ran a test against it just to analyze, to see, and they were smaller. But yes, the point is, your fingers still typed more when you do test-driven development, for sure. There's no denying that. And so, like, go ahead.
I have a quick question. So are you talking about the expressive test in this scenario? Is that correct to say?
Say that again?
UI test or the expressive test?
You can do, this would be a unit test, just to do the functionality of that. Was that your question?
Really, this is kind of end-to-end test, right?
Mm.
You will be doing more of expressive or UI testing. So you need to consider the resource idling of things. I would say about the resource, like then if you are doing the UI test,
Mm-hmm.
unit tests are faster, yeah, they are cheap to write. But when you are doing the UI, like functionality testing, this is more of UI test, not really the unit test.
Sure, but it depends on the way you've abstracted your patterns, right? So if you're doing MVVM as an approach, or modified presenter, however you're doing it, you can, right now I was just giving you an example of, yeah, when this user does this, but the UI is separate, from the actual level of functionality that does it, right? So you can write another one for that, right? In this case, because we worked in a team, we were just doing the functionality layer. We were just doing the manager or the presenter work or the view model, if you will. Yeah, but that's a good point, is that you can write this like for different levels of that application as well. So I might not really care what the UI is doing in this layer, but I might in the next. Yes. And in case 3, as a user, I want to log into the app to access the system. Okay, to me, all of these seemed like pretty simple requests, right? Kotlin does a really good job of making a lot of this easy, but I had to stop and think, right? I had to stop and think about how I do this. So now that you've kind of had a little bit of a taste of how much you have to break it down, let me show you what kind of saved me a little bit, okay? I was able to search online, and an anonymous writer, otherwise I would credit them, created the 5-step method of easy TDD. which I'm like, glory, hallelujah. Because right now, that's so much thinking about how to break things down. I need to be able to automate this in my brain, right? Number one, decide the inputs and outputs. So I'm like, okay, decide the input. I know that I'm going to need this, and I know I'm going to want that at the end. We start this process from a high level. We don't care about the implementation just yet. We have the goal, calculate password strength. To get to that goal, we usually need some inputs, right? And then we get some output based on them. So when you normally start writing code to get to some goal, you'd probably start with a function. You'd probably think of what data the function needs to work and what kind of results it will give back, right? We can start this process by doing exactly that. We just won't write any code for it yet. Okay, so how would this work? The input is easy. It just has to be the password, right? The output is also easy. It has to be some value describing the strength of the password, right? It's for a validator. To keep things simple, let's say the password is either strong or it isn't. So we can use a Boolean value for the input, for the output, okay? So the input is password, and then the output is a bool, okay? Then I have to choose the function signature, right? So now that we know what data goes in and what comes out, we need to choose the function signature. So that is what the parameters the function takes and whether it returns something. This step is, again, very similar to what we've been doing forever. You kind of approach writing code without TDD, just like this, right? Before you can write any code for a function, you need to decide what all this is. So none of this has deviated from the traditional coding methods that I've done. But first are the parameters. What does our function need to work? In this case, it's simple. All it requires is the password, right? We can do the whole calculation based entirely on that value and that value alone. But what about the return value? Simple, since this is a calculation, we can return the result directly, right? In some more complex cases, the return value might be a promise or some sort of additional change method. But instead of returning a value, the function might take a callback parameter, or it might just not return anything at all. It could just be a void, right? Either way, at this point, we can now decide what calling the function would look like in code. So now we finally get to touch it. Ta-da! Okay, now we have written our first line of production code. Hooray. Okay, cool. Next, we decide on one aspect of functionality. We now know that the goal, the data involved in the function signature, right? In a non-TDD workflow, you jump into writing code for the function now. You might already have some ideas on how this would work, right? I know I do. I think really rapidly. We need to check for this, we need to check for that, we have to return value is affected by this, right? This is how most people run into trouble with TDD, including yours truly. Because my head was filled with all these ideas on how to write the function, but I'm not sure of exactly how to lay out the code until you start writing it. Like I want to touch the protection code now, right? I'm visualizing it in my head. So instead of thinking of all the choices, let's focus on just one tiny thing for now. So what is the simplest possible behavior that we need to get a tiny bit closer to our goal, right? So a common problem is to try and tackle a chunk of behavior that's really big, right? Because that's what makes me get up in the morning. This is what makes me code. If we think of password strength, there's ideas of different rules like special characters and numbers, password length, etc. And of course, it's hard to think of a test that would cover every one of those situations, right? So what is the simplest possible step we can take to make this function be a little closer to the ultimate goal of validating a password, right? What would be the very first line or two of code that I could write if I built this function without TDD, right? What is the smallest amount? The very simplest rule for password strength might be the empty password, right? That's really easy. So the output should always be false when the password is empty. That's something you can write. And so thus, I was able to finally start adding my various conditions. Cases, I started with the easiest one, whether or not something's null, whether or not something's empty. That's usually how I was able to very quickly just add some tests right in the beginning, and then I started thinking about them as we went. Number 4 is that you implement the test, right? The main difference is that instead of focusing on implementing the function, we're focusing on how the function would be called and what happens as a result. So that is that we're thinking about the function and how it behaves under some conditions. So how the function behaves is what we want to test. Once you start testing behavior under some conditions like time of day or whatever, testing becomes a lot easier because we can look at behavior from the outside. We don't need to know the implementation if we're just choosing behavior. And that blew my mind because I think in code. But this made me think like a client. And that broke my brain a little bit. But the good artifact from that is that it did make me be a little bit closer to the humanity of the project, okay? We decided the function takes a password as its only parameter, okay? We also decided it returns a Boolean to indicate whether the password was strong or not, right? We also chose that for an empty password, the result should always be false to indicate an empty password is weak, all right? Implemented that, pretty easy. And number 5, we finally implemented the code. So these are the 5 steps that I was able to break down and think about that really started me to go. Because I don't do well without examples. I need to know examples of how to do things. The problem is, that takes away creativity. If I just look at an example of a red-green refactor test, I will always think that way. That takes away almost all the creativity on how I think about problems, because I will only ever do it this way. So this 5 steps kind of allowed me to still kind of retake the creative part of my brain. Because implement code, it's very self-explanatory, right? We'll just add the smallest amount of code that makes the test pass, right? If we were to continue developing the password strength function, all we do is just repeat steps 1 through 5. Or, sorry, 3 through 5, yes, 3 through 5, that's correct. And choose the next tiny step to make. Step 4, add test. Step 5, implement, repeat. That's all I did. That's it. And really, we're already doing that. Anyway, without TDD, we just didn't think about it formally. So then it stopped feeling so foreign, right? If you keep advancing in small steps like this, TDD suddenly becomes a lot easier. Yes, you might end up with several tests for a very small amount of code, but that's not a bad thing, okay? So TDD kind of helps you in this way to reduce the amount of useless code you might otherwise write. You're not really sure if it really affects it, because you can give it a cursory glance. And have you ever done this where you've asked a peer or perhaps a senior above you to look at it and they see something right away? You're like, you don't need to assign that to a variable, just return the result. Why are you doing that? That's just an extra step. It does work, but it's a waste of code. Why are you doing that? And this actually prevents that from ever happening when you think about it. Because every line of code you add is verified by a test. So you're not allowed to write production code without a test. It's the most wonderful and an infuriating process I think I've ever been through. But it taught me a lot of lessons about how quickly my brain skips to the next exciting thing instead of taking the steps in between. I'd be terrible at being able to program a robot, because if I just say, okay, you gotta walk and you gotta turn right and then left. Yeah, but what does it take to run? What does it take to walk? What takes a step? Well, what is a step? Like, I have to put my heel down first and then the middle of my foot and then step on my, there's a lot of tiny pieces to it. But because we've had these wonderful object-oriented programming languages for so long, we don't think that way. We're like, go run there and turn right, because we have extra functions that just go do that for us. So this kind of allowed me to take a step back almost on that robotic level, which sounded really tedious, but it actually made me find ways to make things even more efficient than what the framework allowed me to do. That was an interesting kind of takeaway. So speaking of takeaways, let's talk about some key ones, shall we? If you do TDD with Kotlin specifically, it will avoid over-architecting, right? With tightly focused coding work on acceptance criteria, right? It only is allowed to do things that the acceptance criteria tells you to do and what the tests tell you to do. It provides confidence that those cascading code changes are flagged by failing tests. So the moment you do something that changes anything, it really does tell you. What I love specifically about doing it in Kotlin is because it adds that human readable style of executable test phrasing. That is awesome. Because I don't know about you, but instead of looking at that, I'd rather look at that. Much, much better. I know it's not a lot of detail, but this thing right here probably saved me hours of debugging just being able to read that, okay? Because when you're starting to be in a large group of people, every minute is really important. Wall of text meant for robots, information meant for humans, you know? I, for one, would definitely go for the second one, but I know people who would prefer the first, you know? That's my fallible opinion anyway, right? So what do you think? Yeah? Thank you very much for listening to me today. If you have any more questions about the journey that you too can go on to doing TDD with Kotlin, I'll be just outside. Thank you very much.